Hey everyone, today we're going to build an API in Express using the Sequelize ORM. We're going to interact with the same SQLite database that we've been using, so this one right here. Let's go ahead and get started. I've already created this project that just has an empty app.js file. It has the getIgnore file that's going to ignore node modules, and then package.json with an empty object. So we'll list our dependencies here. So let's go to our command line and install all the necessary packages. So here I'm installing Express, Sequelize, SQLite 3, and then body parser, which I'll explain a little bit later. If you use the -- save flag, this will write it out to the package.json file. Okay, so let's go ahead and start up our server. So I'll say nodemon app.js. Let's go to our editor. So let's go ahead and pull in Express. I'll say const express is equal to require express. Then I'll also pull in Sequelize. So the first thing that we need to do is create our Express app. So I'll say app is equal to Express. So the stuff that we learned last class. And I'll say app.listen on port 8000. And then we'll have an empty endpoint. So maybe we'll interact with that playlist table. So I'll say app get / API / playlist, and this will receive the request and response object, and we'll just kind of return all playlists. But the first thing, kind of before we get to the definition of this route, is we need to connect to our Sequelize database. So what we can do is we can say const Sequelize is equal to a new instance of Sequelize. And this will take a string, so it takes in SQLite, colon, and then the name of the database, or the path to it, which is chinook.db. So kind of like what we did with Eloquent in Laravel, is we had to first create a model in order to start interacting with the ORM. So I'm going to do the same. I'm going to create a model, and this one will be called playlist. And this one we can call Sequelize.define. So the first parameter is kind of like the name of the table, but the singular version. So in this case, I'll say playlist. And then we can pass it some options. So on my model, I'm going to have a property called ID, and this is just going to alias to that primary key, the field called playlist ID. So you'll see that in the database schema. So the next thing we can do is also define what type of data that it contains. So this one we can say Sequelize.integer. And then the last piece is we're going to tell it that this is the primary key. So I'm going to say primary key is true. Now the playlist also has a name. So the column is capital N name, but I don't want to call it that. I just want to use lowercase name. So I'm going to remap it, and I'll say the field is name. And then the type is Sequelize.string. And then the last piece is this, every model kind of expects a set of timestamps, just like Eloquent did, but because our tables don't contain the created at and updated at time fields for timestamps, I'm going to disable this. So I'm going to say timestamps false. You could go ahead and add this, but I don't really want to modify the database. Okay, so now we can go to our route, and then we can call find all off this playlist model. So I can say playlist.findAll. And this will do a SQL query to get all the playlists from the playlist table. And then this will return a promise. And this promise will resolve with the list of playlists. So I can say playlist here, and then I can say response.json and just send down this array of playlists. So let's go ahead and test this out in the browser. Okay, so now we can see that it returns a list of playlists. Great. Now going back to our project, I don't want to define our model in this one file alone. I want to give it a little bit more organization, kind of like what we saw in Laravel. So let's kind of break this out a little bit more. So I'm going to create a folder called models, and I'm also going to create another folder called database. And so if we look at this, we have this one instance of Sequelize. So this is like our database configuration. This is what we need in order to create a model in the first place. So I'm going to put this one configuration in a single file. And I'm going to put this inside database. So I'll say new file. We'll call this config. You know what? Maybe we call this Sequelize.js. We'll paste that here. And so in order for this file to know about Sequelize, we need to pull in Sequelize over here. So we're going to go back and grab this. So copy this, paste it at the top. And in order to kind of expose this, what we can do is we say module.exports. And this is using a module system called common.js. So in order to expose things from a file, we need to attach it as module.exports. So we're pulling in Sequelize, we're creating a new instance, and then we export it as module.exports. So now we can go back to our app.js file. I'm going to minimize this. Okay, so now let's also put this playlist model in its own file. So I'm going to go into the models directory and then create a new file, and I'll call this playlist.js. And I'll go back here and copy this. And I'm going to say module.exports is equal to this. So this is the playlist module. But this also needs access to this Sequelize variable that's inside this database folder. So let's pull this in. So I'm going to say const Sequelize is equal to require. Now, typically, if we just say the name of the package, like we did with Express and Sequelize, we would get access to it and it would look for it in this node modules directory. But in this case, this is we're just pulling kind of a relative file path. So what we can do is say from our current directory, let's go up and then into the database folder and grab access to this Sequelize file. So we can leave off the .js. It's implied, so we'll just pass in the relative path to require, and this will give us access to this module that was exported. So we'll pull this in and then export it out. And looking at our playlist, we also actually need access to Sequelize because there's some constants on this class. So we can go ahead and just copy this line and paste this here as well. So we actually need access to both. And if we go back to our app.js file, now we should be able to get rid of this, and we should be able to get rid of Sequelize too. I'll just comment it for now because actually I think we're going to need it a little bit later. And let's pull in playlist now. So I'm going to say const playlist is equal to require, so models/playlist. And so if we go back to our browser, in theory, this should still work. Refresh, everything looks okay. Okay, so all we did was use this common.js module system, that's the module system in Node, to kind of break things out into separate files since we're going to start creating a bunch more models. So playlist, all it contains is access to the Sequelize class and then the instance, which is inside database Sequelize. Now let's go to our app and let's create another route, but for finding a single playlist. So I'm going to copy this route, and this one's going to be /API/playlist::ID. So this will return a single playlist resource. Instead of calling find all, we can use the method called find by PK. And this will take in the ID. So the ID we can get access to from the request. So we can say let ID is equal to request.params.id. There's also a handy syntax in newer versions of JavaScript. So if the variable that you're assigning to is equal to this property, we're kind of duplicating ID twice. We can actually use a syntax like this. So let ID is equal to request params. And this is called destructuring. So it kind of makes things a little bit more terse. You don't have to use this, but why not? Okay, so now find by PK, it will resolve with a single playlist. So let's rename this variable. And let's check this out in the browser. So I'll go and visit playlist/2, which is movies. We can see a movie being returned. Now, what happens if we pass in something that doesn't exist? Well, it returns back null. So typically when something isn't found, a 404 status code is returned. And if we look at our console in the network panel and refresh, we can see that 200 is being returned. So to make this more conventional, let's return a 404 status code. So whenever you kind of visit a website or click a link and the page isn't found, usually see 404, and that's like the HTTP status code for not found. Let's do the same in our API. So find by BK will return a promise that resolves with null if the thing isn't found. So here we can just add a little if statement and say, if there's a playlist, then we will return it as JSON. Otherwise, I'll say response.status 404.send. So this is going to have an empty response body, but the status code will be 404. So now if I refresh, you can see 404 wasn't found. So let's go back and revisit our playlist endpoint, and what we're going to do is pass in a query string param that will filter down a list of playlists return. So if I were to go to my browser and go to playlists, I want to be able to do something like this where I say Q is equal to maybe R, and this will return all the playlists that start with R. So maybe R isn't actually a good name. Maybe we do something like M. So in theory, this would return music, movies, the second movies, music videos, and yeah. So what we can do in our endpoint is we're going to define an object. So we're going to say, we'll call this filter, and this will just be an empty object. And we'll say if there's request.query.queue, then we're going to say filter is equal to an object that actually has something. So in the event that queue doesn't exist, filter will just be an empty object. And here we're going to pass it this where option. So it's kind of like a where clause. We'll say where the name of the playlist. And we want to say kind of like a SQL-like statement. We're going to say, so like, well, let me finish this. I'll say like $Q. So it's going to start with whatever Q is, and then anything after it doesn't matter. So percent. So it's kind of like Q percent. So what goes here? Well, we kind of want to say like, and the Sequelize gives us this thing called op, and it's a symbol. So we can say Sequelize.op.like, and we haven't really seen a key like this before. So typically keys are like strings like this, and it has some type of value. But here you can use brackets and pass in what's called a symbol, and a symbol is kind of like a newer JavaScript feature, but it allows you to kind of create like a unique key. So here we can actually go to the Chrome console, and you can see I can create a symbol, and we can give it kind of some value. So I'll say let is A is equal to symbol. And so A is a symbol, but you can use these symbols as like a key value. So that's what's kind of going on here. So Sequelize.op.like. And we can actually reduce this so that we don't have to type this in every single time. So maybe we do something at the top. We say const, kind of like that same destructuring as before. We're going to say op is equal to Sequelize, because we're actually going to, if we wanted to use this in several spots, like typing all this out over and over again would get maybe a little repetitive. So now we can kind of shorten this up a bit and say like, and we can get rid of this. And then so we define this filter object, and we can just pass in this filter to find all. So when that Q query string param exists, then we're going to pass in filter will be defined as this when we pass it in, otherwise it'll be an empty object. And one thing I actually forgot was Q, so we actually need to save this into a variable. So I'm going to say let Q is equal to request.query.Q, and I'll change this to be if Q, and that same destructuring as before, because I'm using Q here and Q here, we can just change this to Q and then get rid of this. And so let's go ahead and try this out. So I'll go to my browser, refresh, and we can see now we're only getting back the movies that start, or the playlists that start with M. And if I get rid of the query string param, we get back everything. So this is essentially how you can do a where clause using Sequelize. So let's move along and let's create endpoints for artists and albums. So I'm going to start off by creating an endpoint called artists, and this will return just, an endpoint for artist/ID, and this will return a resource, an artist resource. And we can essentially copy out this route right here. So I'm just going to copy this and just change a few things. So in this case, it's not playlist, it's going to be artists. And then instead of playlist, we'll have an artist model, which we'll define in a minute. And instead of playlist, I'll rename this to be artist. Okay, so now let's go ahead and define this artist module. So I'll go back up here. I'm just going to copy this and paste it and rename this to artist and this to artist. And this doesn't exist yet, so let's go to our models. And I'm just going to actually just duplicate the playlist one and call it artist because it's going to be pretty similar. So the one thing that will change here is artist, and the primary key for the artist table is artist ID. And then the artist has a name, and I think that should be the only thing that's that we have to define. And while we're at it, let's actually just do the same thing and create an album model. So I'm going to duplicate this. Rename this to album. And this will be album ID. And the album, I believe it's title. So let's look at this. Album, yes, it's title. So we'll call this title, and we'll change this property to be just lowercase title. Okay, so let's go back and let's kind of import this into our app.js file. So I'll call this album, and we'll say let's require album. So hopefully everything just still works. So let me just refresh playlist to make sure this is all cool. Looks like it's all working. Okay, so things are probably good. So we created this endpoint artist ID. So let's go ahead and try this. I'll say API/artist/50. Okay, and so we get Metallica. Great. Now, wouldn't it be nice if this artist endpoint returned the associated albums for that artist? So the relationship. So if we look at the database schema, we can see that an artist will have many albums, but an album belongs to a single artist. So it's that one-to-many relationship. So how can we model this in Sequelize? So at the top of our file, let's just define the relationships here. So I'm going to say artist, and we call a method on it called hasMany. And so it's going to hasMany album. Now the second argument is an object, and this is where we can tell it the foreign key. So we're going to say foreign key. And here we're going to say artist ID. And so that's all we really need to do to define this relationship. So let's actually do the reverse of this. So the album, if you kind of remember from when we did Eloquent, there was hasMany and belongs to. So in this case, an album belongs to an artist. And this will also take this foreign key as well. So we'll just copy that and paste that in here. So we define the relationship between these two models. So let's go back, and I'm going to collapse these playlist endpoints. We'll revisit them in a little bit, but I just want to focus on this endpoint right here. And let's make sure everything still works, so we still get back this artist resource. Now let's say I want to return another property called albums, that includes all of the associated albums with this particular artist. How can we do that? Well, Sequelize makes it really easy for us, and all we have to do is just tell the findByPK method to include it. So right here, as the second argument to findByPK, we're going to say include, and this will take in an array of the associated models that are related to this artist. So in this case, I can say let's include album. And now let's go to our browser and try this out. Now we can see that we're getting back all the albums, and they all have artist ID 50, so it's all the ones just associated with this particular artist. Pretty neat, huh? Okay, so now let's do the reverse. Let's say if I have an endpoint for returning a single album, I want to get the associated artist for that album. So I'm going to copy this here, paste it, and I'll just minimize this one. So this one's actually going to be albums by /ID, and here we'll say album find by PK. And let me comment this one out for a minute, and we'll rename this variable to album. Okay, so let's try this out. So if I visit /album/6, which is Alanis Morissette, let's okay, so we see this endpoint working and it's returning a single album resource. Now I want a property here to be called artist that returns the artist for this album. And so this one is just as simple as the previous endpoint, where I can say include, and I'll say artist. So I'll refresh, and now I can say artist, and then it contains the artist resource. And this is an array, so we can actually include, if there was other relationships here, we can just do comma and pass in the other relationships. So this is how you can do a one-to-many relationship in Sequelize. So using that belongs to and has many. So I'm going to close this a little bit, and now let's go back to our playlist endpoints. So let's go here. Now let's say I wanted to go back, and when I return a playlist, I want to return the associated tracks for that playlist. So the first thing that we need to do, well, let's kind of go back. If we look at this relationship here, this is a many-to-many relationship. And the join table is playlist track, because a track can belong to multiple playlists, but in the playlist can have many tracks. So let's model this relationship. So the first thing that we actually need to do is create a model for a track. So I'm going to go and just duplicate this artist. So I'll say duplicate and rename this to track. And I'll rename artist to track, and the artist ID to track ID, and it already has a name property, so that's fine. So that should be good. So we'll go back to our app.js file, and let's include the track. So we'll say track is equal to require, and then pull in that track module. Okay, so just as we learned, if I wanted to include the relationship, so in this case, I could say something like include track. So when I find a single playlist, include all of its tracks. Now, right now, if we were to go to playlist/1, it's going to hang, and that's because we actually haven't defined the relationship. So this, like I said before, is a many-to-many relationship. So we need to define that here. So what does that look like? So what we can do here is we can say playlist belongs to many, and then we can say track, and then we can pass it a handful of configuration options. So what this looks like is we need to specify the join table, and that's under this property called through. So we're going to say playlist underscore track, and then the foreign key, which is playlist ID. And then we're also going to say timestamps false, because this playlist track table doesn't have any timestamps. So now let's go back and refresh. And we can see under the music, we're returning all the associated tracks for this playlist. And so if we were to kind of look through this, you would see the playlist ID is 1. So that's how you could kind of verify all this. Now, it'd probably actually be beneficial to not include this in the payload, so that's something we can look at later if there's time. So ideally, you just want to say ID is 1 and name, and not include like the join table information. Okay, so let's also do the reverse of this. So I can actually copy this and paste this. And instead of being playlist belongs to many track, I'm going to say track belongs to many playlist. And so this will be the same thing, but instead of playlist ID, this will be track ID. So now if I want to do something kind of like the reverse, and I want to say, give me a single track, or actually, yeah, give me a single track resource, but I want to get all the associated playlists that that track is a part of. Then I'll say track, find it by its primary key, so ID, but I'll include the playlist. And then I'll say, let's rename this to track. So if there's a track, respond it in the JSON, otherwise we'll give a 404. So now let's choose, well, let's try track 1, which we know is part of playlist 1. So I'll rename this to tracks. And we can see it's part of the 2 music playlists because there's, I guess, duplicate, and this other one. So up until this point, we've only done get endpoints, which just read data. Let's create endpoints to create and delete data. So I'm going to minimize this, and I'll minimize these two. So these are kind of our few endpoints. Let's create one where we create data. So I'll just put this at the top just to put it in the middle of the screen. But I'll say app.post. So typically in a REST API, post, the HTTP method post is used for creating data. So let's do the genres endpoint. So I'll say /API/genres function request, get the response. And so typically with a REST API, when you create data, it's post to the resource collection, plural, so genres instead of genre, and then the API will respond with the newly created genre. And okay, so I've already, let's see, did I include genre? So we haven't done genre in here. So maybe, okay, let's actually maybe do artist because we already have artists here. Let's do artists. So here I can say artist.create, and we can pass in an object, and this contains all of the attributes that we're creating with. So in this case, I want to create it with a name. And so what's the actual value here? So I'll just put like an empty string here. And then I can say dot, so this will return a promise because this will do an insert statement into the artist table and then return a promise. And once it successfully inserts, then we'll get access to the artist that was created. And then I can say response.json. Okay, so for now, I'm just gonna put my name here. So it'll just be something made up, and then we'll modify this to receive this value from the request. So how do we go about testing this endpoint? So there's some good software out there called Postman, and this allows us to make HTTP requests. So go ahead and download this, and it's just like an app. So I'll open this on my computer. Okay, so if I make a post request to API/artist and hit send, okay, so what are we getting back? We are getting back a response. So this is the newly created artist, but the ID is null. So why is that? So it turns out after some debugging, what we actually need to pass to this model is this property auto increment true. And this is probably because this field is like an auto incrementing value. So maybe Sequelize knows to kind of re-pull this value. I'm not exactly sure why, but either way, this is probably just something good that you want to have on all your primary keys. So let's try this out again. And now you can see that the ID is being populated. Okay, so the next piece is, instead of hard coding this value, I want to pull this from the request. And so the way we can do this is saying request.body.name. And so the body property will contain the payload. So what we can do is, we're in this post request, we're going to send it a JSON payload that contains a property of name that contains the value. So if I were to go back to Postman, and if I were to go to body here, so I was testing this out earlier, but instead of my genre, I'll say, let's see, artist, some new artist. And if I hit send, okay, so now we're getting an error and it says cannot read property name of undefined. And that's because Express out of the box doesn't parse request body, and we need a piece of middleware in order to parse JSON request bodies. So that's actually what we did when we first installed things. We installed this body parser library. So what we can actually do is go back up here, and I'll say body parser is equal to require body parser. So once we've initialized our Express app, I can say app.use, and I can say body parser.json. And this will add a piece of middleware for parsing request JSON request bodies. So that's really all we have to do is install that little piece of middleware. So if we go back to our Postman, if I resend this, you can see some new artist was sent, and now we can see the response contains it. It was 200 OK. So great, it looks like it's working. Now, typically when you're inserting data into a database, you want to do some type of validation before you do the insert. And one of the great things about Sequelize is that it comes pre-installed with some hooks to work with a popular validation library called validate.js. And so on our artist model, we can actually define all of these validations per attribute. So in this case, for this name attribute, I can create a property called validate, and we're going to declaratively specify validations for this field. So one of the things I want to do is say it's basically required. So here I can say args true, and then give it a message. And so I can say name is required. So so this is basically saying it's required, and then this will be the validation message if it fails. So we can actually define a few more while we're at it. Let's say that the name has to be, it can only contain letters. That's not maybe the most practical thing, but just to show you that you can do other validation rules, there's another one called is alpha. So we're going to say this is true, and then the message is name must only contain letters. And let's maybe do one more. Let's say that there has to be a length. So there's a property called len, and the args is, we can say it has to be between 2 and 10 characters. And then the message is name must be between 2 and 10 characters. So there's a bunch of validation rules, and you can specify on this property. So let's give this a try. Let's purposely change our body. So I'll make it empty to start with. And I'll say send. Okay, so right now it looks like it's hanging, and that's because if we go to our app.js, so when we go to this post request, it tries to create this, but this function won't get called because it's the promise is not resolving. Instead, it's actually giving us a rejected promise. So we need to actually put in the rejection handler here, and this will receive the errors. So now I could actually say response.json errors. Let's go back. Do send. Okay, so now we can see all the errors. And if we look at this a little bit, we can see that errors is an array, and then here's that message. So name is required, name must only contain letters, and it must be between 2 and 10 characters. So we probably don't want to send out all this stuff because as a consumer, this is just like too much information that they don't really care about. Let's remap this just to maybe an object with a message property. Okay, so I'll kind of go back to this, and I'll say, I'll pass in an object here, and there will be a key called errors, and we're going to loop over this errors object and just return a just the message of each. So I can say, so we can use the map method for this. If you're not familiar with map is a function on arrays that allows you to take one array and convert it to a new array. So in this case, errors is an array, and I want to map each one of these error objects that we saw here, so each one of these things, and I just want to extract out the message. So I can say, so this will essentially loop through it, and each item will be represented as this variable error, and I can say return error.message. So errors will be, here will be a key, the key in the payload that contains a new array just of the message. So if I go back and resend, okay, so I may have an error. Oh, errors.map is not a function. Okay, so let me see what errors is. Let me just do a console log of errors. So if I send this, look at my console. Okay, so let's see, errors looks like, oh, there's a property called errors in this. So maybe what I should actually do is, we'll go back and rename this to response maybe, and we can say response.errors, and we'll map over each one and then get the error. So now if I go back, let's retry this. Okay, so let's see, I'm still having some problems. Let's see, let's look at this a little bit more. Response.json, oh. Okay, so now I'm calling it response, which overrode this one. Let's call this, let's see. All right, let's call this validation. We'll say validation errors. Okay. Refresh. Okay, so now we're extracting out the message. So you can think of like if you had a front end and you got back these error messages, you can display them at the top somewhere. Now you probably would want to include the key name, because the key would be able to, like if this said name and then the message, then you'd be able to pick out the key so that you could attach these messages closer to like where the field is. Otherwise you wouldn't know like where to put these messages on the page. So I think including the key might be useful. So maybe instead of just returning the message, let's return an object instead that says message, error.message, and then we'll also include the field name or the attribute. So I'll call it attribute and I'll say error.path. And this is what it was like when we originally logged it out, but you could look at that if you want to see the raw one. But now we can see something like, okay, so the failing attribute is name, and here's the message. Okay, so if we look at this response, it's actually still sending 200 okay. Generally, when you get like an error response where the thing being created failed server-side validation, the typical status code is actually 422. So we can say status 422 and then send out that JSON. So now if I refresh, okay, so 422, it stands for unprocessable entity. So that usually just means server-side validation errors. So the last one I want to do is I want to create an endpoint for deleting a resource. And if we look at the SQLite, if we look at the SQLite database schema, I think maybe a good one to do is let's delete a playlist. So looking at this schema, we can see that there's this join table, and it contains the playlist ID and then the track ID for that track. And so if we delete a playlist here, that means we also need to clean up the data in this join table, because say we had a playlist ID of 6 and we delete that playlist and we remove the record from this table, but that means this table is still referencing something like playlist ID 6, but that doesn't exist. And so typically this is that would be called an orphaned record. And so there's two ways you can handle it. We could say, okay, let's clean up all these records first before deleting. So clean up all the records in this table where the playlist ID is 6, and then delete playlist ID is 6 from this table. So that's one way to handle it. Another way to handle it would be to use what's called a soft delete. So in this case, in our playlist table, we could maybe have a column called deleted at, kind of like the created at column, and this would contain a timestamp for when you intend to delete it. So we could say something like delete the playlist ID 6 from this table, but instead of actually deleting it from the table, we'll just update that deleted at column with the timestamps of when we said we're deleting it. And so we're essentially keeping the data, but we're just adding a value to that deleted at column. And then inside of your like get endpoints for playlist, we would just not include the ones that have a deleted at timestamp. So this way you can kind of preserve data. I would probably go that route, because then you can keep data and you can reference it later. But let's do an example where we actually destroy this data, just so you can see what's involved. And then, for your projects or whatever, I'd probably recommend going the deleted at column, but just something to think about depending on your situation. Okay, so let's add another endpoint here. And so I'm going to say app.delete. And I'll say we'll make a request to API/playlist/ID. So I want to delete a single playlist. So we'll pass in the request and get the response. Okay, so how would we do this? So I think the first thing that we want to do is find the playlist that we want to delete in the first place. So I can say let ID is equal to request.params. So we're extracting out this ID, just like with the get endpoint for finding a single resource. And let's actually just start by destroying just that playlist. So we can see what happens when we try and delete this record, but then we leave orphaned records in this join table. So I'm going to say, okay, so let's find it. So we're going to say playlist.findByPK. We'll pass in the ID. And then we can pass in, so what will get passed to us is the playlist. And so we can call playlist.destroy. And this will actually do the delete request. And so this will return us a promise. And so typically when we just have a delete endpoint, we can say response, and the status code is usually 204, which means it was successful, but there's no response body because we're not going to send anything back. Sometimes some people will send the thing that was deleted. In this case, I'm going to just not return a response body. It'll just be empty, and so the status code for that is 204 most of the time. And we'll just call send, because we're going to not send a body. So set the status to 204 and then send it. Okay, so let's go ahead and check this out. All right, so let's go back and open up Postman. And I'm going to change this to, clear all these. I'm going to choose delete. And I'm going to say, let's delete playlist 1. Okay, so if you look at this, it's hanging, so there's probably an error. So let's check out our console. Okay, and then we're seeing SQLite constraint, foreign key constraint failed. And you can see actually what the SQL that was trying to be run. So we first found that playlist by its ID, which was 1, and then we try and delete it. And so there's it's a little bit more complicated SQL, but essentially that's what it's doing. It's deleting that single playlist, but it fails because there's a constraint in the database that says if you try and delete something and there are other records associated to it, it won't let you. And so that's what this is. So you can actually enforce that constraint at the database level. So what we actually need to do is delete all of the records in here with a playlist ID of 1 before deleting playlist 1 from this table. So it gets a little bit more complicated. So how can we do this? Okay, so let's go back to our handler and comment this out for a second. Okay, so from this playlist object, there's actually a method for us that we can use called, I can say set tracks to an empty array. And so what this will actually do is there's a relationship between a playlist and its tracks because we define that relationship above. So we're setting it to an empty array. So this alone will actually just delete the records. And kind of after this finishes, so this will return us a promise. And then once this finishes, then we can call this right here. So I'll uncomment this. So we'll delete all the tracks from that join table, then we'll destroy the record, and then we'll send that response. Okay, so let's go ahead and try this out in Postman. Okay, so 204 no content. So it did get to there. And if we look at the command line, playlist 1 actually, I think had a lot of tracks. So if you scroll up, you can see, okay, so here's the first SQL statement that says, let's find the playlist by ID 1. And then here we're seeing delete from playlist track from that join table where playlist ID is equal to 1, and then track ID is in, and then all the track IDs for that playlist. So there's actually quite a few, so it's deleting all of them. So now there's 0, and it did get here. So let's actually clean this up a little bit. And so one of the interesting things with promises is from a then callback, we can actually return a promise. So I'm going to break this out onto just multiple lines here, just reformat it a little bit. So here I can say dot then. And so, so the first thing I can do is I can move this down here. And instead of, so I can say return playlist.destroy and then delete this. And so from within this promise chain, I can say I can return this, which is also a promise. And then this one will kick in kind of once this resolves. And then we also actually need to, right here, we need to say return. So this will return a promise, which will resolve once, once this resolves, then it will call this. And so we can essentially return promises from within like other then calls. And so we can kind of break this up a little bit. So this will actually give us the same exact, give us the same behavior. Now let's actually modify this because I think we need to add a little bit more error handling. So imagine if somebody tried to delete a playlist that doesn't exist. In that case, this playlist will actually be null. So I can say if there's a playlist, go ahead and do all of this. Otherwise, I want to say response.status. Now, if we try and delete a playlist that doesn't exist, we'll use that 404 status code because that playlist wasn't found, and then we'll send the response. Okay, so one thing I actually noticed was that there were some errors. And so if we go back to this delete request and I hit send, so we already deleted playlist 1 and I hit send, even though it sends 404, we're actually getting some errors here. So if I were to change this and go back and let's delete playlist 2, send, okay, so that's 204 no content, so that's good. And if we look at this, okay, so the terminal looks good, but now let's go back and try and delete 2 again. It says 404, but if we look at our terminal, it's because we got errors, and it's saying cannot remove headers after they are sent to the client. So what is that? If we were to look at this delete request, if there's a playlist, then it'll kind of go through this chunk. But if there isn't a playlist, it's going to do this. But the problem is, the promise chain is going to keep executing. So once this executes, this one will get executed as well. And so the status function will kind of write an HTTP header of the status code of 404. But then this one will get, and then it'll send the response. But then this block will get executed and try and rewrite the header that has already been sent to 204. And so we kind of want to say, hey, stop here. So there's a couple ways we can do this. So instead, we could actually say, let's return promise.reject. So if I reject the promise at this point, right here, then in the next part of the chain, it'll skip the first function in the then call and then call the rejection handler on the second then call. So here I can actually say response status send and do this one. And so if we look at our terminal and then refresh and then try and delete playlist 2, which has already been deleted, we can see that we don't get the error, and then it does say 404. So we kind of fixed that. So one of the so I guess one reason I kind of like this is that in this then block, we're just dealing with sending the response. I mean, the alternative is I could have called then off of this, and then once that resolves, send this, and then likewise here, I could have just moved this right here, put it here. So actually, I'll just do this just to visually show. So I could have, in theory, done this. So if this works, send that. Otherwise, do this, and then just comment this out. And the reason I kind of don't like this is because we get a lot of nesting right here, and we're kind of mixing sending the response along with the actual logic of like deleting things. And I don't know. Personally, I find it just a little bit cleaner if I don't have to, like, I can remove this nesting right here by moving it down here and just returning the promise here. So I guess it's personal choice, but maybe no right or wrong answer here. But I'm going to change this back and do it this way so that if there's a playlist, this will return a promise that resolves once this has finished resolving and this has finished resolving, and then it'll kick in, and then this will happen. And then here, once it hits the else block, when no playlist is found, we're going to reject the promise. So that means this won't get called, but this will get called. And so we can just deal with, sending the response right here. So kind of up to you. And this is kind of where like promises get a little bit complex on just like trying to figure out like how they exactly work. There's a whole specification. If you look up promises A+, I think, you can just see the whole specification on like terminology and like what happens in the then method, and you can just read all about it. But like, so this is just I've just kind of like touched upon it, and so it might be worth reading, but I'd say this is like the majority of cases that you deal with. So then the next piece is like, why didn't I move this thing kind of to its own separate then block? Well, here I actually need access to this playlist variable from when I found the playlist in the first place. So that's why I kind of just dealt with both of them here, right here, like this. So that's why I did that. Anyways, so just to recap, we did get, post, and delete. For your lab, you're actually going to do a patch call. So that means updating a resource. And I'll let you read the description on the site. And it's kind of like a mix between like a get call and a post call, but I'll let you figure it out. So it's just one endpoint and a lab for this. So I'm not going to push this up to Heroku because we already did that with like using Express and the like connects builder. But same kind of deal. You could push this up as well. So let me know if you have any questions.